Right now, somewhere in the universe, a massive star is collapsing. To us, it is dying, crushed by its own gravity into a black hole, from which nothing can ever return. But on the other side of its event horizon, something far more disturbing may be happening. Space may not be ending. It may be beginning again. Some theories suggest that the matter falling into a black hole may never reach a final singularity. Instead, under conditions more extreme than anything we can reproduce, spacetime itself could rebound and expand into an entirely new universe. To us, it would look like a cosmic grave. To anything born beyond the horizon, it might look like a big bang. And if that is true, then every black hole in our cosmos may contain a hidden reality, complete with its own galaxies, stars, planets, and perhaps even life. More unsettling still, our own universe may have been born inside a black hole in another universe. Tonight, we follow this possibility to its darkest consequence. Because black holes may not be the graves of reality. They may be its wombs. Welcome to Cosmic Theory Lab. To understand how something this impossible could happen, we first have to confront the place where our current laws of physics stop giving us answers. A black hole can form when enough matter collapses under the force of its own gravity. Around it lies the event horizon, a boundary beyond which no light, signal, or message can return to the outside universe. Once matter crosses that horizon, every possible path leads deeper inward. According to general relativity, the collapse continues toward a singularity, a region where density and spacetime curvature appear to become infinite, and the equations we use to describe reality stop behaving in a meaningful way. But the singularity is not an object we have discovered. No telescope has photographed it. No instrument has measured it. It is a warning produced by our equations, a sign that the map of reality ends before the journey does. General relativity describes gravity with extraordinary precision on large scales. Quantum mechanics describes matter with extraordinary precision on very small scales. But at the center of a black hole, both should operate at once, and we still do not possess a complete, experimentally confirmed theory that unites them. So the singularity may not be the final destination. It may simply be the place where our current understanding fails. But what if nature never allows an actual singularity to form? Some models suggest that gravity may have one final behavior we have never observed. When compression becomes extreme, enough quantum effects could resist the collapse. Matter might not be crushed into an infinitely small point. The contraction could slow, stop, and reverse. Imagine compressing a spring beyond every ordinary limit. Classical physics says the compression continues toward infinity. Quantum gravity may say something else. The spring snaps back, but not into our space. This hypothetical reversal is sometimes called a quantum bounce. From the outside, nothing would appear to escape. The event horizon would still hide everything that crossed it. But inside, the collapsing matter could open into a new region of spacetime, one that begins expanding away from the point of maximum compression. From our side, matter disappears into darkness. From the other side, that same event may look like a big bang. The true interior of a black hole may not be a room, hidden somewhere inside ordinary space. It may be the beginning of an entirely separate spacetime. A child universe would not need to exist as a tiny globe, physically stored inside the black hole. Space itself could expand on the other side. What appears small, silent, and dark from the parent universe might contain an entire cosmos from within. Time could pass there. Matter could cool. Particles could form. Gravity could gather gas into stars. Stars could organize into galaxies. Planets could orbit suns that never appear in our sky. Entire civilizations might rise, look upward, build telescopes, study ancient radiation, and ask where everything came from. They might conclude that their universe began in an unimaginably hot and dense state. They might call that beginning their Big Bang, and they might never know that their entire reality emerged from the death of a star in another universe. No message from the parent cosmos would reach them. No telescope they constructed could look backward through the event horizon and reveal the world that came before. Their origin would be permanently hidden. But if black holes can create universes, what created ours? The most unsettling possibility is that our Big Bang may have been the same process viewed from the inside. The Big Bang was not simply an explosion of matter into empty space. It was the expansion of space itself from an early hot and dense state. If the interior of a black hole can generate a new, expanding region of spacetime, then the inhabitants of that region may experience only the expansion. For them, it is a beginning. For the parent universe, it is a black hole. If our universe was born this way, then somewhere beyond everything we can observe, there may be a larger reality. Our galaxies, our history, and every human life could exist inside a region that another civilization would see only as darkness. They could orbit the black hole that created us. They could measure its mass, watch matter spiral into it, and never know that an entire universe was unfolding beyond its horizon. From their perspective, our cosmos might be nothing more than a silent object in their sky. From ours, it is everything that has ever existed. If this is true, the night sky above us is not the outside. It is the inside. And the theory becomes stranger still, because newborn universes may not be perfect copies of their parents. One speculative idea, often called cosmological natural selection, imagines that universes could reproduce through black holes. Each child universe might inherit physical laws or constants, slightly different from those of its parent. Some universes might form very few stars. Some might expand too quickly for galaxies to assemble. Some might collapse before complex structures can appear. Those universes would create few black holes and leave behind few descendants. Other universes might produce enormous numbers of stars. Massive stars would live, collapse, and create black holes. Each black hole could produce another universe. Over unimaginable generations, reality could begin to resemble a cosmic family tree. One universe produces 1 billion black holes. Each black hole gives birth to another universe. Some children leave no descendants. Others create countless black holes and reproduce again. In this picture, universes themselves begin to evolve. And that leads to a darker possibility. Perhaps the universe is not fine-tuned for life. Perhaps life exists because the universe is fine-tuned for death. The deaths of stars that create black holes, carbon, planets, biology, and consciousness may not be the purpose of the system at all. They may be side effects of a cosmos, optimized to build massive stars and collapse them. Stars may not be the final product of the universe. They may be its reproductive machinery. But this remains a hypothesis, not a discovery. There is no evidence that every black hole creates a universe. We do not yet possess a tested theory capable of describing what truly replaces the singularity. Different models produce different answers. Quantum gravity may prevent infinite collapse without creating a separate cosmos. The interior may behave in ways no current theory predicts. And even if a child universe exists, the event horizon may make direct confirmation impossible. The hypothesis survives not because it has been proven, but because the physics at the center of a black hole remains unfinished. The evidence may be locked behind the one boundary nature designed to keep secrets. Yet if this possibility is even partly correct, the consequence is almost impossible to comprehend. Reality would not be a single event with one beginning. It would be a family tree. A star dies, a horizon forms. A universe begins. That universe creates stars of its own. Some of those stars collapse, producing another generation of realities. Creation would not stand opposite destruction. Creation would be hidden inside it. Perhaps no universe ever witnesses the birth of its children, and perhaps no universe can ever see its parent. From our side, a star dies. From the other side, the clock begins. Perhaps the Big Bang was not the first moment of everything. Perhaps it was the final moment of something else. This is Cosmic Theory Lab, where the darkest objects in the universe may be hiding its greatest acts of creation. If this theory changed the way you see black holes, subscribe and tell us in the comments. Are black holes the end of reality, or the beginning of something we can never reach?